So if we end up with something to the power of 2 equals b, you can square root the stuff. All right? So you could say, look, I'm going to apply a principle of equality by square rooting both sides. And yeah, sometimes we may be looking at binomials or trinomials, right? It's just, if you ever square root a power of 2, you have to take both the positive and the negative of that square root. Okay, and this goes back to, it's something to the power of 2. So if you looked at something that was like, hey, look, a squared equals 25 like this, you'd say, well, I can square root both sides, and that'd be great because a would be 5, right? Well, 5 works because 5 times 5 is 25. But since we square rooted something that was being squared already, the negative will apply as well. Because negative 5 times negative 5 is still positive 25. So you got to look at both. In fact, kind of like we would see with not square roots, but absolute values. So if I saw something like that, where I saw a squared equals, I'll do a different one like 36. If I had to take the square root of both of these, I like to split it up in two separate equations, where then you'd have a equals 6 and then a equals negative 6. Now again, will it just always be 36? No, it could be something like minus x squared. So, something like this, and then you take the positive and negatives of those. It wouldn't be 6 though, so I changed it. I feel like I should change it back. That's better. Okay, but the principles of equality still apply. It's just now, and I've talked about this before, if you have a power of 2 in the problem, you should have 2 answers. Sometimes it's only, you have the same answer twice, but we should expect to start seeing 2 answers for the most part. Now, like we've seen though with exponents, square roots as well, you need to check your answers, because if it's outside the domain, which it shouldn't be, but if it were to be outside the domain, then you can't use it. Okay, so always go back to the original equation and check the 2 answers that you get. Okay, so on this one, all right, this is an equation. It's not really quadratic. We don't want to change it to a quadratic because I can solve this because I have something to the power of 2 equals something else, right? Like we saw, a squared equals b. So I can square root both of these, right? And then the square root of the power of 2 just leaves me with what's inside there, h minus 3. And then this would equal the square root of 21. But I guess I should at this point. This is where I would split this up. Okay, so I have h minus 3 for both. But they're going to equal not just the square root of 21, but also the negative square root of 21. Okay, because we're expecting to see 2 answers now. So if I were to solve these, I would actually solve them the same way. I'd say for both of them, I'm just going to add 3 to both sides. Right, that's going to zero out our minus 3s. That leaves me with just h equals on both. Now, these are not like terms that I can combine. I mean, there are constants, but the square root of 21, I'm going to treat that like a separate term. So this is going to be 3 plus the square root of 21. And then this one over here is going to be 3 minus the square root of 21. Now, I'm not going to do this. I'm not going to necessarily perform the check. I still recommend that you do. But the original equation was h minus 3, I'm giving myself space there, squared, equals the square root of 21. And if you were to replace that h with either one of the ones that we just found, 3 plus the square root of 21 like this, and you put that in the calculator, I'm sorry, it's not the square root of 21, it's just 21. If you put this into the calculator, you will get 21. And it would be true also if you put negative or minus right there, okay? So both of these are solutions. Let me specify that. So I put in the question mark over here. We found it's true because it would give us 21 equals 21. And again, this would be true also if you made a 3 minus the square root of 21, minus 3. Now, everyone knows 3 minus 3 is 0, so that zeroes out. So you'd have the negative square root of 21 to the power of 2, which is 21. Well, even if it's positive as well.